So good morning student. So finally class 11th chemistry, the chapter of today's equilibrium. So today we are going to understand what is chemical equilibrium. Basically we have to deal with two type of equilibrium. One is chemical equilibrium and the second part is ionic equilibrium. But there is only one unit in your textbook, that is chemical equilibrium, or you can say equilibrium. So first of all, let us try to understand what is equilibrium. Before starting this, we would like to explain a chemical reaction. Means a chemical reaction, as you know, is maybe of two types. Okay, chemical reaction may be of two types. One is irreversible reaction and one is reversible reaction. As it can be easily indicated, like suppose if there is any product A is converting into B. So this is a single arrow and we can say that this is a irreversible reaction. If A, the arrow is like this, B means A is converting into B, at the same time B is also converting into A. So this is the sign of irreversible reaction. So basically we have two types of reaction. One is irreversible reaction and one is reversible reaction. So what is irreversible reaction? You can say it. Irreversible reaction is that this reaction is one-sided reaction in which equilibrium never attains, because equilibrium is the state where the rate of the forward reaction and rate of the backward reaction becomes equal. Later on we will understand it, but first we have to note down these points. The second one is reactants may convert it into product, but product cannot be converted into reactants. Means this is the example. If A is converting into B, means B cannot be converted into A. So this is the point. Next, it can be completed, means the irreversible reaction can be completed. Okay, it will complete. So the next we have to understand what are the reversible reaction, student. Like this, I have explained you, A is converting into B and B can also be converted into A. So similarly, in which reactants and product there is a equilibrium, the sign is, it is sign of equilibrium, in which reactant and product will be in equilibrium. Means these are double-sided reaction. These reactions will be double-sided reaction. The second point, reactant cannot completely convert it into product and product give back to reactant. Okay, as I explained you before. So now what is equilibrium? So you can understand, when rate of forward reaction is equal to the rate of backward reaction, that stage is considered as equilibrium. Okay, the equilibrium attains in reversible reaction is called dynamic. Basically we have two types of equilibrium, student. I am going to understand it, I am going to explain it. Sorry, there are two types of equilibrium. One is static equilibrium and one is dynamic equilibrium. Okay, so what is static equilibrium? Means कोई भी चीज रुकी हुई, static. So that equilibrium is known as static equilibrium. And dynamic, which is on motion, means dynamic equilibrium. Suppose this is any object, you have applied a force from here and you have applied force from here, means you are going to stretch it. आप दोनों तरफ से इसको खींच रहे, मींस इट विल बी इन इक्विलिब्रियम, बिकॉज द फोर्स जो आपने यहां अप्लाई किया ये इसके इक्वल हो जाएगा. तो मींस ये चीज क्या है? स्टैटिक. ये क्या है? स्टैटिक है. तो डायनामिक इक्विलिब्रियम क्या है जो हमने एक्सप्लेन किया अभी? व्हेन द रेट ऑफ फॉरवर्ड रिएक्शन इज कन्वर्टेड इज इक्वल टू द रेट ऑफ बैकवर्ड रिएक्शन, that stage is considered as equilibrium. The equilibrium attains in irreversible reaction is always dynamic. Means whatever the equilibrium will attain in any irreversible reaction, that will be dynamic equilibrium. It means it can be changed depending upon the reaction condition. This equilibrium can be changed. For example, I'm going to write an example. For example, you have, this is very common reaction, N2 plus 3H2 gives 2 moles of NH3 plus heat, some amount of heat. Okay, so what will happen? This indicates heat, तो लिख दिया ऐसे. तो देखिएगा क्या होगा. This is nitrogen and hydrogen will combine to form ammonia, and the ammonia will also decompose into nitrogen and hydrogen. So at which time the equilibrium will attain? When the rate of forward reaction. What is the forward reaction? N2 and H2 are combining to form ammonia gas. So the rate for this reaction will be RF. And if the ammonia will decompose into N2 and H2, this will equal to rate of backward reaction. So when rate of forward reaction will equal to rate of backward reaction. So this condition is known as equilibrium. This condition is known as equilibrium. So this you can write from here also. So there are some thermodynamical aspect also, but initially we are not required for that. So only you can note down it. Okay. So now next we are going to understand that what is equilibrium. So equilibrium can be of two types. As we know, one is physical equilibrium and second is chemical equilibrium. Okay. When the equilibrium occurs without any chemical changes, when there is no any chemical change, then this type of equilibrium we can say it is physical equilibrium, student. Like water जो कि ice है 0 degree Celsius पे, it can be converted into liquid, means solid is converting into liquid, but the chemical composition, the chemical, there is no any chemical change. Water is water, whatever it will be ice or liquid. So 273 Kelvin at 1 atm pressure, the solid can be easily converted into liquid. So what is chemical equilibrium, student? When the equilibrium occurs with a definite chemical change, it's called chemical equilibrium. Means, for example, I had given you the reaction also like this. N2 plus 3s2. This is also ammonia and hydrogen मिलके क्या बना रहे हैं? Ammonia बना रहे हैं. So means chemical composition change हो गया. So that means this equilibrium is kind of chemical equilibrium. Okay. Another type of reaction is this. H2 plus I2 gives 2HI. So this chemical equilibria can also be classified into two categories. One is homogeneous and one is heterogeneous. So what is homogeneous? Means when all the reactants and product exist in a single same phase. Means H2 gas, I2 gas, 2HI gas. This is called homogeneous. And heterogeneous means when any one of have the different phase. Means when all the reactant and product are not exist in the same phase. This type of equilibrium is known as heterogeneous equilibrium. Okay. So student, note down the very important point. In homogeneous equilibrium, when there is only liquid phase, when there is liquid phase, homogeneous means it can be all the reactant and product can be liquid, can be gas, can be solid. All, suppose this is only all are gases form. If all the substance, reactant and product are in liquid phase, then we can consider a constant, that is Kc will be considered. And when the reactants or products will be in gaseous phase, then both Kp and Kc can be considered. So later on we will understand it, what is Kp, Kc. And first we have to understand, when all the reactant and product are in liquid stage, liquid phase, then only Kc will be considered. And when they are in gaseous state, then both Kp and Kc will considered. Okay. So next we are going to understand what is Kp and what is Kc. Okay. So before understand this, there are some characteristics. Okay. There are some characteristics. So make your heading characteristics. Okay. Characteristics of chemical equilibrium. Characteristics of chemical equilibrium. Chemical equilibrium. As you all know, chemical equilibrium is dynamic in nature. It is a student dynamic in nature. As now you can understand what is dynamic. So equilibrium, okay, in equilibrium, catalyst enhance the both forward and backward reaction. Okay, what is the effect of catalyst on equilibrium? So later on we can understand it. So to understand this, suppose you have any kind of reaction. For example, you have a reaction. For example, A plus B is giving C plus D. Okay, A plus B is giving C plus D. So I can write it the for forward reaction RF, for backward reaction rate of backward reaction. Okay, so similarly, if I am writing rate of reaction is directly proportional to what? According to active mass, law of mass action. So the rate of reaction is directly proportional to the product of the active masses of the reactant. This is A and B are the reactant, directly proportional to the concentration of A and concentration of B. So this bracket indicates that this is active mass of A, this bracket indicates the active mass of B. So simply this is the student law of mass action. Means the rate of reaction is directly proportional to the active mass, the product of the active mass of reactant raised to the power of their stoichiometric coefficient. Suppose if there is stoichiometric coefficient A into A plus B into B, so in that case this small a will go to the power, this small b will go to the power. So this is rate of reaction. Similarly, rate of backward reaction, student, rate of reaction. So this is for forward and this is for backward. So it will also directly proportional to. So for backward reaction, this will be reactant, this will be product for backward reaction. So in that case, this will directly proportional to the active mass of C into active mass of D. For example, small c and small d are the stoichiometric coefficient. So small c into small d. Okay. So now what will happen at equilibrium? At equilibrium, rate of forward reaction will be equal to rate of backward reaction. So to remove this proportionality sign, you can write it. Rate of forward reaction is equal to Kf is any constant Kf into active mass of A to the power A into active mass of B to the power B. Similarly, the rate of backward reaction will be equal to, I can write it for this, Kb into C to the power C into D to the power D. Okay, simple. So now at equilibrium, rate of forward reaction will be equal to rate of backward reaction. So on that case, Kf into A to the power A into B to the power B will be equal to Kb into C to the power C into D to the power D. Okay. So I can write it Kf upon Kb. Kf upon Kb will be equal to what? C to the power C into D to the power D divided by this A to the power A into B to the power B. Okay. So this is at equilibrium, this rate of forward reaction over rate of backward reaction, their ratio Kf over Kb, I can write it Kc. So Kc can be equal to this C into C into D divided by A into A into B into B. You can consider any kind of reaction. So today I'm trying to explain you what is Kc. Kc is basically, student, equilibrium constant. This Kc is known as equilibrium constant. This Kc is known as equilibrium constant. So for any reaction, applying the law of mass action, you can easily understand what is the equilibrium constant or what is law of mass action. So to further explain it, I'm going to show you this law of mass action. Okay, you can note it from here also. This is the law of mass action. Okay, you can make your notes by taking the screenshot also. Okay, so this Kc is known as equilibrium constant. Okay, so this is basically, student, law of mass action. Our first lecture based on the basic introduction of this equilibrium. As you can understand what is equilibrium, what is static and what is dynamic equilibrium. So in our next video we will understand what is two types of equilibrium constant, that is Kp and Kc. So in our next video we will explain what is Kp and what is Kc. So as we know, Kc is what? Equilibrium constant. So now what is Kp? So in our next video we will understand and how we can calculate Kp and Kc for a given reaction. Then we will understand what is the relation between Kp and Kc. So let us try to understand it from your NCERT book also. So make a proper notes and submit it. So let's finish it. So मिलते हैं आप सभी लोग के साथ नेक्स्ट वीडियो में. टिल देन, थैंक यू वेरी मच एंड हैव अ नाइस डे.